Hello everyone, this is your SmartTechie. In this video, we are going to learn about different API architectural styles. Due to vibe coding and a lot of AI usage in terms of writing code, learning these fundamentals to develop applications is very much essential. That's why I started recording these API architectural styles in these videos. I am starting with REST, explaining what is REST, how to use REST, when to use REST, pros and cons of REST, and then GraphQL, gRPC, and then WebSockets. In this video, let us explore REST API architectural. Now let us see what is REST. REST is an API architectural style by which we can access or modify the data hosted in a remote server using HTTP protocol. REST strictly follows HTTP standards as well as HTTP spec. By saying that, so when you are using REST APIs, definitely we follow resource oriented design. So we are going to expose the APIs as resources like /user to access the user information, to access a specific product's information like /product/ID. And we uses HTTP methods like get, post, put, patch, delete to perform any CRUD operations using REST APIs. To respond back to the client, we definitely use HTTP status codes like 2xx, 3xx, 4xx, 5xx, these kind of status codes. And REST is stateless protocol where REST client has to carry the entire information to the server so that server can process and respond back. The data interaction between the REST client and the REST server happens by using JavaScript object notation or XML based. So these are all pretty much very standard HTTP stuff because REST strictly follows HTTP spec. There are some problems, so we will see what are the problems we are going to face with REST API architectural styles. In this scenario, we do have a client and a server. The communication between client and server happens like this. The client is making an API call to get a slice of pizza, and server doesn't understand the client request in a proper way because server knows, okay, if I get any API call to this particular endpoint, I know what is the response I have to send it back to the client. So we designed the API that way. So here the server is responding with a slice of pizza along with the soda information. And client is not happy because server is sending the extra information which client doesn't want. So this kind of scenarios we always face when we are consuming any REST API. We get hundreds of data fields as part of the response, but we consume very minimal fields out of that response. So that's why most of the times client receives a lot of information from the server, but we don't use it. This is one of the scenario, and now client is thinking that it is overfetching the information from the server. To avoid this overfetching problem, when we design the system such that we are going to define the granular APIs. In this case, we define an API endpoint to return only the pizza information, and the other client is asking the soda information from the server. Here we do have /soda API endpoint at the server. So server is able to serve only the soda information. Here, some clients are happy, some clients are not happy because some clients are ending up making more API calls to get the data rather than getting everything in one API response or in one API call. Because making more calls over the network is going to create a lot of performance problems. So that is the reason some clients are unhappy. So we call this as underfetching problem. So here, if you look at, we are trying to solve overfetching problem, but we are ending up creating underfetching problem because some clients are not fetching the information in one API call, rather they are making multiple API calls. So these are the two major problems we face with REST API architectural style. To avoid these overfetching and underfetching problems, generally we go with like client specific APIs. In this case, if you look at, we do have thin clients as well as thick clients, and we have an API gateway to intercept the API requests, and accordingly from which client the API request is coming, we will route that API request to the specific APIs. For example, we have an e-commerce application and we exposed APIs for our clients. So here there are mobile clients, and the UX user experience for mobile clients is different than desktop clients. So for that reason, we slimmed the APIs to send the specific response to mobile devices or tablet devices. So in this case, we created different APIs for mobiles, tablets, and desktop APIs. Now the API gateway is going to take care of how to route the APIs to the respective API servers, and all the clients are happy. But the problem with this approach is we increased the capital expenditure, that is setting up more servers, more infrastructure, as well as operational expenses where we need to deploy more developers, more QA engineers to test these APIs and maintain these APIs. So REST is creating so many problems: overfetching, underfetching, and then more expenses when we have different set of APIs based on the client needs. Here, pros and cons on REST. So essentially, REST is very simple and standard because it is simple to develop any REST API endpoint. If you take any programming language, any framework, it is very simple and it is very standard, and it is widely adopted because when you are using HTTP, because a lot of web applications, the internet based applications uses HTTP protocol, so obviously REST is it goes hand in hand with the HTTP protocol, and it caching friendly because REST APIs you can cache it because it follows HTTP spec, so obviously HTTP APIs are cache friendly. And the cons are we have over and underfetching problems and worsening overhead. So these days the APIs are evolving so fast. So when you have REST APIs and if you want to add more features, so you need to create version 1, version 2 like that, and then you need to make the deprecation notice to the client saying that we are having newer versions, we are going to drop the older versions, so you guys need to move your clients to consume the latest versions. So the versioning overhead is more. Until all the clients are consuming the latest versions, we need to manage the older versions. So it's kind of overhead. And no real-time support. When I say no real-time support, that means until unless client makes API call to the server, client doesn't know what is happening and what kind of updates server is having it. For example, we do have an e-commerce application where we hosted so many REST APIs and there are different clients consuming our product catalog APIs. So in this case, we as the service providers are updating different products information in our catalog. Until clients makes the request, they don't know what updates are happening on our product catalog. Otherwise, they will be displaying the stale information on their applications. So server is having the updates, but clients doesn't know until they make the API call. That's a reason behind no real-time support. And performance issues. So obviously when you are making more number of features, the API also will be growing, so obviously it is going to create some performance issues. So those are all the cons. Now let us see when and why to use REST. So obviously, when you have CRUD operations like create, read, update, delete tasks, so obviously you can use REST, and it uses standard protocol built on HTTP, widely understood and supported, because most of the development team, one or other way, either they might be creating REST APIs or consuming REST APIs. So team is very well versed with REST API standards and simple data formats, human readable data, because it uses JSON or XML. And most of the front end frameworks, when they are making the API call, so when they consume the JSON response, it is easy for them to render that on the JavaScript frameworks. And simple integration, suitable for simple, easy to maintain APIs. If you don't have any real time needs, for example, it's client's responsibility to make the request to get the response, so we don't require any real time updates from the server. Yes, it is easy to use REST. And the final thing is, when you don't know the other API architectural styles and you don't know whether the other API architectural styles are needed or not, it is better to go with REST. So start with REST and then you evolve or adapt new API architectural styles. Now let us see a simple Spring Boot based REST application. So in this REST application, we wanted to create a product, add some product reviews and get product information. So this is a simple REST based application. So here we are using Spring Boot based framework. So essentially a Spring Boot, we are using Spring Boot Web as well as JPA, and then in-memory database, which is H2 database, to store the product information and the reviews information. So if you look at the kind of APIs we exposed, so there is a post API to create a product, and get API to get the product information based on the ID, and adding product reviews. So for a specific or given product, we are going to add certain reviews. So we have an entity for product as well as reviews, and a model, those are Java records, to expose the response back to the caller, and then the repository to store product information as well as reviews information, and a service layer. So pretty much this is a very simple REST API based application to make API calls for the product catalog, where we store products and add reviews. So I started the application, and now the REST API application is running, and the APIs what we created as part of product controller are available to access through any REST based client. So here I am using Bruno, which is one of the REST based API client, REST API client, I would say. So here what I'm doing is I'm trying to access the API to create a product. So I'm just creating a product with name and sale price, and internally the H2 database. So we created entity to auto generate the product ID. So if you send this, we will receive the headers as well as the response saying that this is 200 status code with OK, and then the response is the product ID, name, sale price, reviews. So now let us add reviews to this particular product ID. So here we are trying to add some reviews. So I'm just storing the product ID as part of the variable. So I'm just getting that product ID as one here and then adding the reviews. So now I have added reviews to the product which we created. So reviews are a list of reviews. If you want to get the product which we created, which is product ID 1, so we are able to get how essentially the REST APIs are going to work. As we are discussing about REST, I wanted to explain another important aspect when we are using REST API architectural style. If we are using REST based APIs, so when we are making the API call, if you look at the API call is going or using HTTP 1.1 version. Right now we are already moving to HTTP 3 and a lot of people are already using HTTP 2, but still REST APIs are using HTTP 1.1 because a lot of servers are supporting HTTP 2, but most of them are not supporting, or the clients are not supporting HTTP 2. So we still uses HTTP 1.1, which is not as efficient as HTTP 2. And as I told, the data is exchanged with text-based information like JSON or XML, so which goes as the text representation. So here, if you look at the response is coming from the server in pure text response. So sending any text representations over the network or over the wire, which takes a lot of size in terms of bytes, so obviously it puts more burden on the network. So this is one of the aspect to reduce the performance of the APIs. So these are the things we can explore by using tool called Wireshark. So I just wanted to explain that. I hope you enjoyed this video, which is explaining REST API architectural style along with various pros and cons. Until we see next API architectural style, that is GraphQL, in another video, see you then.